Hi everyone, I'm Fred from the Australian National University, and I will be presenting our upcoming work for ICCV 2021, titled Spatially Conditioned Graphs for Detecting Human-Object Interactions. Detecting human-object interactions involves the localization of interactive human-object pairs and the recognition of that activity. These images demonstrate the desired outputs. They might look simple enough, but there are many challenges for this task. For example, there are much more complex scenes with a plethora of humans and objects, and interactions could be very ambiguous as well, but more importantly, there are an overwhelming number of negative examples. This is due to the combinatorial nature of human-object pairs, and the total number of pairs is quadratic to the number of instances. This makes it difficult to devise the correct correspondence, that is, which person is holding which umbrella or riding which bike. And this is precisely the motivation of this work. We adopted a graphical model for its capacity to infer from context, and proposed to apply spatial conditioning to the graph. Now, for conventional models, each node sends identical messages to all its neighbors, and previous works only use one modality in the messages, usually the appearance. But we propose to condition the appearance messages on the relative spatial information between a pair of nodes, resulting in different messages tailored to the receiving nodes. For the full model, we first run an off-the-shelf object detector to get a set of bounding boxes, confidence scores, and object classes. Then for the proposed spatially conditioned graph, we use the appearance features as node features, and some learned spatial encodings as the edge features. Specifically, due to the heterogeneous nature of nodes, we employ a bipartite graph as shown on the left, with human nodes on one side and object nodes on the other. The message functions, denoted by capital M, are parameterized differently depending on the direction, resulting in anisotropic messages. These messages will then be weighted by learned adjacency values, alphas, that characterize the connectivity of the graph. On the right, we show how the node features and edge features are combined to compute the adjacency, messages, and class logits through a proposed MBF module. For the MBF module, as the name suggests, it fuses two modalities under a multi-branch structure. The intuition is similar to the ResNext model, where homogeneous branches with reduced feature dimensions are employed to encourage diversity. Our method has demonstrated superior performance on popular datasets. On Qualitative, we show that our method significantly outperforms the next best method when using a fine-tuned detector or an oracle detector that supplies ground truth object detections. We also observe that our method slightly underperforms when using a pre-trained detector. To investigate, we applied Gaussian noise to both modalities and observed that for high-quality detections, that is, with a fine-tuned detector, noise in spatial features damages the model more, while for a pre-trained detector, noise in both modalities appears to cause the same amount of damage. Therefore, we conclude that the spatial conditioning greatly contributed to our model's performance gain when using high-quality detections. For qualitative results, we show that our model correctly infers the correspondence between human-object pairs involved in the same interaction. However, we do notice that for the same image on the right, instance 2 and 3 have been incorrectly assigned a high score for riding a bike, indicating that our model struggles with overlapping objects. Lastly, we show that, as a nice surprise, the computed adjacency matrices are able to reflect the interactive pairs to some extent without explicit supervision. For the top right figure, it shows that person 2 puts a high weight on the incoming message from object 6. Same for person 3 and object 5. Both are interactive human-object pairs. And we can see a similar behavior from the bottom right figure, when the matrix is normalized by columns, supporting the same argument. Thank you for taking an interest in our work, and have a great day.